Welcome back. In this video, we're going to graph quadratics using the TI-84. So in this video, I'll show you how to find the x-intercepts, the y-intercept, which really won't be necessary, but also the vertex, or the maximum or minimum point. So let's take a look at the graph of f of x equals x squared minus 3x minus 10. Well, we should already know some things about this particular graph. Since a is equal to 1, we should know, or a is positive, we should know our parabola opens upward. And we also know since a is equal to 1, this is also going to have what we call our standard width. The y-intercept we should be able to eyeball because that's where x is 0. So we know the y-intercept is going to occur at 0, negative 10. The x-intercepts, well, if we can factor it, we know where the x-intercepts are, and this one, it turns out, we can factor. So this one's a pretty easy one to work with. 0 equals x minus 5 times x plus 2. So our x-intercepts are at 5 and at negative 2. Our vertex, well, we know our vertex is going to fall right in between 5 and negative 2, or we could do the opposite of b over 2a. That would at least give us the x-coordinate of the vertex. And the opposite of b over 2a is 3/2. And that, of course, is right in between 5 and negative 2. Well, let's go ahead and see if we can back this up with the graphing calculator. So to input our function into the graphing calculator, go to our y equals screen, that's our f of x, and input x squared minus 3x minus 10. And we will go ahead and take a look at our window. Let's just try and graph this in the standard window and see what we get. So we hit zoom standard, and we almost get the entire graph into our window. So let's go ahead and make a little adjustment. It looks like our range of x's was fine. Our scale counting by ones makes sense. Our y minimum, though, we needed to go a little bit lower. So let's see how much further we need to go. Let's try the y minimum of 15. Let's keep our y max at 10, that's fine, and our scale by ones. And we'll hit graph again and take a look and see what we get. So that looks a little bit better. Now we can see our vertex. We can kind of eyeball and confirm what we already knew about our x-intercepts, or our zeros are at 5 and negative 2, or appear to be that. And, you know, we can trace, hit the trace key, and we can trace along our parabola and kind of guess where our vertex is going to be. Okay? And we can trace and try and catch our x-intercepts, but we're not quite there. So let's see if we can find the x-intercepts. Let's go ahead and do that first. So the x-intercepts can be found under the calculator key. So on the trace key, but the blue part, second calc, we want to find the zeros. Okay, zeros is another word for the x-intercepts. So find the zeros, and it's asking us for the left bound. You and I, we can just look at this. We know where to look for the x-intercepts. The calculator doesn't, so it asks us, how far left do I need to look? Well, that seems to be fine where we are right now. It doesn't have to look any further than about 4. So we enter. Now it's asking for a right bound. How far to the right should I look? Okay, and we're up around 6 here, so we'll hit enter. So now with these arrows pointing in towards each other, that means the calculator is going to search for the x-intercept for any x value in this particular range. So kind of between 4 and 6. It's asking for a guess. We're not going to guess. We'll just hit enter again. And sure enough, it tells us that this particular 0 is at 5, 0. And that is what we confirmed when we factored. And we would follow the same process for finding the other x-intercept, the other 0. It's asking for a left bound. So we need to move all the way. So I'm just hitting the arrow key here, all the way to the left. And we could input a value too. I may have gone too far. Okay. So here I am at, around 3, or negative 3. That's far enough left. And right bound, enter again. So it's going to hunt in between here. In between, it looks like negative 1.2 and negative 3. I'm not going to guess. I just hit enter, and sure enough, it confirms my other 0 at negative 2, 0. And finally, let's find the vertex. Well, it didn't give us any kind of command under the calc screen for vertex, but it did give us an option for a minimum or a maximum. And since our parabola opens upward, we know that the vertex is the minimum. We know that this isn't going to go any lower than the vertex. Okay, we're not going to go any lower than that. So our vertex is our minimum point. So we go to second calc, and let's go ahead and find the minimum. And it follows the same process. Calculator says, how far left should I look? How do I need to look at any x's further than left than negative 1.5? And I don't. So hit enter, a right bound. How far right do I need to look? So we need to get to a point that's to the right of our vertex. And we're looking good here at about 3.4. And so it's going to look in this range. It'll select x's in here and try and find the minimum y. Guess. And sure enough, at 1.5 or 3/2, negative 12.25. That is the ordered pair for our vertex. So here you go. Let's try something a little bit more challenging. Let's take a look at f of x equals negative 3x squared minus 12x plus 4. Well, we should know, since a is negative, that our parabola is going to open down, which means our vertex will be a maximum. That's the highest point. The absolute value of a is 3, which means our parabola is going to be pretty narrow. Our y-intercept is at 0.4, and our x-intercepts, well, we could try and factor this. It's not going to be factorable. We could use the quadratic formula, or we can go ahead and try and use our graphing calculator. So let's graph negative 3, and I'm using the minus sign here, negative 3x squared, or I should say the negative, the one in parentheses. Negative 3x squared minus 12x plus 4. And let's go ahead and do zoom standard. We'll graph that in the standard window, and wow, that totally doesn't fit. So, I'm not sure I need, it's very narrow, and we predicted that. So I'm not sure I need all these x's in my window, and I certainly need some more y's in my window. So I need to go higher on the x-axis and not as higher on the y-axis and not as wide on the x-axis. So x min of negative 10, probably don't need that. Probably -5 is fine. And an x max of 5. I'll still count by ones. Y min of -10. We'll try -5. And let's do a y max of 20. We're going to have to go quite a bit higher. We'll still count by ones. Hit graph again. Let's see what we get here. That looks really good. So we're from -5 to 5, counting by ones on the x. I can see my vertex. I can see my x-intercepts. Well, let's go ahead and find our x-intercepts. They are not integers as they were in the previous one. So we'll do second calc, and we want to find the zeros, the x-intercepts of the zeros. It's asking for a left bound. Well, let's find this one that's close to between 0 and 1 first. So left bound, enter. And let's go to about 1 here. So right bound, so it's going to search in this region. That should be good enough, I guess. And we get 0.3094. That looks like some sort of irrational number. So we're going to have some sort of square root, I bet, if we do the quadratic formula to find out exactly what they are. So let's go ahead and find the other x-intercept, the other 0. Again, it's asking for a left bound, so I need to go to the left of where that is. Oh, it even moved over for me. Beautiful. Enter. And a right bound. We need to have x values, an x value that's to the right of it. That will work. So it'll search in this region for x's. And a guess. Enter. And, well, that's almost 0. That's 0.0000, that's 12 zeros and a 3. So that's close to 0, so about -4.30. And again, probably some sort of square root for our x-intercepts. We would have to do the quadratic formula to find out exactly what it is. The opposite of 12 plus or minus the square root of -12 squared minus 4 times -3 times 4 all over 2 times -3. So it looks like our axis of symmetry is going to be at -2. Opposite of b over 2a is -2. And it sure looks that way on our graph. So we can confirm that by finding the maximum value. So we'll go to second calc or second trace and find the maximum. Left bound, looks good. Let's trace over. Got to get somewhere to the right of our vertex. Enter, enter, and sure enough, our maximum occurs at the axis of symmetry, x equals -2 and y equals 16. So there's a couple samples of how to use your graphing calculator to help you find some of the key points on a quadratic function, and we will see you in class.